It was supposed to redefine aviation efficiency, but behind the 777X's breakthroughs lies one of Boeing's most turbulent programs ever. The Boeing 777X combines revolutionary engineering with unprecedented challenges, revealing how pushing aviation limits reshapes the future of flight. Here's the thing about commercial aviation. Real breakthroughs rarely happen overnight. Most new aircraft arrive quietly, offering slightly better fuel burn, slightly longer range, slightly nicer cabins, incremental progress, safe progress. And then Boeing announced the 777X. This wasn't a refresh. It wasn't a tweak, it was a statement. A twin-engine aircraft aiming to do what only four-engine giants used to handle: massive capacity, ultra-long range, global flagship routes. Before things get complicated, let's break down the two versions, because they tell you exactly what Boeing was aiming for. The 777-8 is the long-range specialist, around 395 passengers, but with a range stretching roughly 8,745 nautical miles. This is the aircraft built for ultra-long routes, missions where efficiency matters more than sheer size. Then there's the 7779. Bigger, longer, louder presence at the gate, around 426 passengers with a range of just over 7,285 nautical miles. This one is all about capacity, replacing older 777-300 ERS and even stepping into territory once owned by the 747 and A380. Different missions, same ambition. Both aircraft were designed to give airlines something they desperately wanted: a 380-like capacity without A380-level operating costs, fewer engines, less fuel, lower cost per seat, and on paper, it looked unstoppable. Now this is where the 777X truly separates itself. The wing. At 235 feet, the 777X has the largest wingspan of any commercial aircraft ever built. That's not marketing fluff, that's physics. Bigger wings mean better lift, better efficiency, and lower fuel burn at cruise. But here's the catch. Bigger wings usually mean heavier wings, and heavy wings kill efficiency. So Boeing ditched aluminum. Instead, the 777X wing is built almost entirely from carbon fiber reinforced polymer composites, borrowing lessons learned from the 787 Dreamliner. Same philosophy, scaled way up. Lighter structure, stronger materials, more flexibility under load. The wing area increased by about 15% compared to earlier 777s. The aspect ratio jumped from 9:1 to 10:1, which is a big deal aerodynamically. Less drag, more lift, better cruise efficiency. Boeing also reduced the wing's sweep. That subtle change improved the lift-to-drag ratio even further, especially at long-haul cruise altitudes. All of this unlocked something critical: more fuel without massive weight penalties. Fuel capacity climbed to over 350,000 pounds, extending range and giving airlines flexibility they didn't have before. This wing isn't just bigger, it's smarter, and it quietly does most of the efficiency work people usually credit to engines. Wait, you're watching right now but not subscribed to the channel? Go ahead and smash that subscribe button so we can move on with the video. You did? Okay. Why? Cool. Now back to the story. And then there's the engine, the heart of the whole program. The GE9X isn't just big, it's absurdly big. A 134-inch fan, wider than the fuselage of a Boeing 737. 16 composite fan blades, down from the GE90's 22, cutting drag and weight while pushing more air than any commercial engine ever built. This thing operates at a 61:1 overall pressure ratio. For context, older wide-body engines sat closer to 40:1. The GE9X's high-pressure compressor alone hits 27:1. That means hotter combustion, better efficiency, and less fuel burned per pound of thrust. Certified thrust ranges from 93,000 to 110,000 pounds. But during testing, the engine hit a jaw-dropping 134,300 pounds of thrust, a world record set in 2017. So why not certify it higher? Because Boeing and GE wanted a margin. Reliability, room for wear, heat, and real-world abuse. Certified thrust stayed conservative to protect long-term durability. Fuel burn improved by roughly 10% compared to the GE 9115B. Emissions dropped sharply. Noise levels fell. The bypass ratio climbed to 10:1, pushing propulsive efficiency even further. On paper, it was everything airlines wanted. And yet, this is also where the story starts to bend in unexpected ways.
At Boeing, we build airplanes for people, by design, connected to the sky. And we welcome you to fly with the 777X. We endeavor to create comfort and harmony through the principles of our cabin philosophy. Better experiences mean more joy, wonder, and delight.
Now zoom inside the airplane. The 777X cabin is subtly wider, but it matters. Airlines can finally offer true 18-inch economy seats without squeezing shoulders together. That alone changes long-haul comfort. Boeing carried over the best parts of the 787. Large dimmable windows, improved humidity, and a lower cabin altitude that leaves passengers feeling less exhausted after long flights. Sound insulation is better too. The cabin feels calmer, quieter, less mechanical fatigue, smoother cruise. It's still unmistakably a 777 inside, but everything feels slightly more refined. On flights pushing 14 or 15 hours, those small changes add up fast. But here's where the story starts to wobble. The original plan was simple. First deliveries around 2019 or 2020. Clean timeline. Confident messaging. The first 7779 finally took off on January 25th, 2020, flying for just under 4 hours before landing back at Boeing Field. On the surface, it looked like a win, but behind the scenes, problems were already brewing. GE engineers had discovered early wear in the high-pressure compressor stator vanes. Exhaust gas temperatures were running higher than expected. Components weren't aging the way simulations predicted. That forced redesigns, rework, and delays, pushing engine certification into late 2019 and shifting the entire flight test schedule. Nothing catastrophic yet, but the warning lights were flashing. This was the moment when the 777X stopped being just an ambitious airplane and started becoming a very complicated one. And then things got worse. GE had to redesign parts of the high-pressure compressor, pulling multiple compliance engines back from Boeing for fixes. Certification slipped. The first flight slipped. Everything slipped. Then, in November 2022, another bomb dropped. During routine testing, a GE9X engine shut down after a temperature alert. The engine involved had logged more than 1,700 hours and 2,600 cycles, exactly the kind of real-world usage Boeing needed to validate reliability. Boeing paused flight testing. GE launched an investigation. Emirates started asking uncomfortable questions. Was this a one-off issue? Or was it something deeper in the engine's design? GE eventually traced the issue to a combustor liner problem, corrected it, and flight testing resumed in 2024. But by then, confidence had already taken a hit. The GE9X wasn't failing, but it wasn't settling down either. And for a program already years late, that uncertainty was poison. The financial damage was brutal. In Q3 2025, Boeing reported a $5.3 billion net loss. Buried inside, that was a $4.9 billion one-time charge tied directly to 777X certification delays. That single charge alone nearly wiped out earnings expectations. Total charges on the program have now crossed $15 billion. Boeing officially classified the 777X as a reach-forward loss program, meaning it will not recover development costs on the first 500 aircraft sold. That's an enormous admission for a flagship jet. CEO statements made it clear this charge was meant to clean the slate, not drag the problem into future quarters. But the damage was already done. Investors noticed, airlines noticed, regulators noticed. The 777X was no longer just an engineering challenge, it was a financial one. Originally, the 777X was supposed to enter service around 2020. Now? 2027. That's a 7-year delay. Major customers like Emirates, Qatar Airways, and Lufthansa have had to reshuffle fleet plans, extend aging aircraft, and absorb operational headaches. As of now, 26 aircraft have been built. 4 are flying in the test program. The remaining 22 sit in storage, waiting for certification. The FAA has moved the program into Phase 3 certification, with intense oversight shaped by the 737 MAX fallout. And yet, despite everything, the 777X still matters. When it finally enters service, it will deliver efficiency levels no aircraft of its size has ever achieved. The industry still needs it. The question isn't whether the 777X is advanced. It's whether the cost of getting there was too high. The Boeing 777X is both a triumph and a warning. It proves aviation can still leap forward, but only at immense cost. When it finally enters service, the 777X won't just carry passengers. It will carry the lessons of how close modern engineering can push the limits of flight.